I'm Chuck Schuster. I'm a retired extension educator. I served in the Montgomery County office for a couple decades, and I didn't do well at retirement, so I'm still doing things, especially teaching. And I hold the certification on the ag side. I hold the certification on the turf side. So I have both urban and ag.
Can everybody hear okay?
Yes, can you hear me? Do I need to use a microphone?
You good?
Okay, good.
We do have the microphone frame. The speakers
Yes.
aren't quite as loud.
For your university folks, here is the obligatory series of slides. University of Maryland programs are open to all, regardless of any of your beliefs or desires. So we are open to all. With that, with that, this is the Injustice for All poster. This says that this is a complaint procedure. If we do anything in our programs that you feel is egregious, this is the procedure that you would go through to file a complaint through USDA against the educator or the extension office. So, okay, so today, this is a touchy mouse.
Do you want to just use the computer?
I'm just going to use. Here is my email address, cfs@umd.edu. If you have any questions, please don't hesitate to reach out to me. I'd be glad to provide assistance, answer questions. I believe in this program. I will tell you that. I really do believe in this program. My office currently, I serve out of the Carroll County Extension office. So if you need me, you can reach me there. So what are we looking at today? Why are we here? So my portion of the talk is we're looking at, this whole idea of why are we so worried about nutrients, and why does the state of Maryland seemingly have such strict regulations, and are they worth it? And if they are worth it, what are we doing with those regulations and how are they helping us? So water pollution, that's really why we are here. We have this great estuary, the Chesapeake Bay, but we follow that back. We follow that back to the local streams. And we look at water quality in those local streams, which ultimately influences the Chesapeake Bay. So we don't want to forget that everything we do, no matter how far we are from the Chesapeake Bay, as long as we're in the watershed, plays a role in the quality of the bay. We have a lot of very unique challenges. Our soils are not identical across this whole region, throughout this whole watershed, and we have to understand that. The bottom line is we are looking at providing nutrients to crops without affecting crop yield. Now, we can drive crop yield to a point where return on investment no longer makes sense. So we have to look at that balance. Where do we stop the addition of nutrients going onto a crop and timing of that nutrient going onto a crop and still remain profitable? So we're going to think about that. We look at these things called best management practices. Things that we can do, things that we have developed as part of the nutrient management program. And by the way, just simply good stewardship that are going to promote a healthier Chesapeake Bay. So, I don't know how many of you have followed the Chesapeake Bay report card over the past several decades. I have. I started teaching my first basically Chesapeake Bay cleanup, pollution reduction workshops going back into the late 1970s. So, we did something back in the mid 1970s where we eliminated phosphate from detergent. Phosphate, similar to the phosphate we're using as a nutrient source. We did that as a way of trying to protect water. But, we're growing crops. And, you look at the state of Maryland, and, depending on where you sit, you might not recognize just how important the cropping and the agriculture is. So we're doing these things and we grow Crops vary intensely, such as the Eastern Shore. Their crop is poultry. They grow some grain. Then you get into different sections, and we have fruit and vegetable. We have the whole grain world: corn, wheat, soybeans, barley, things like that. And we look at that, and we have to look at how we're going to manage them and manage not to create pollution. But it's not just agriculture. We have lots of cities and towns and homes that are on septics and things like that. They all play a role. And we look at what we are flushing through the system from homes and going through wastewater treatment plants, and that includes pharmaceuticals. Of recent years, we're finding the PFAS concerns that we're seeing. So there's a lot of different things that are going, and we also need to remember that the more impervious surface we have, the greater the flush of just sediment that got onto the street that ends up in stormwater management systems that eventually ends up in the bag also. Now, we're moving people, we're moving goods. How many of you had trouble getting here today? How was traffic? When I came in, it wasn't too bad. There are days in which getting to Annapolis has been a challenge for me. But you think about the byproducts that we're putting out, and those byproducts getting mixed with the water in the stormwater system and eventually ending up in the bay, they play a role. And we think about the additives that we are putting in our fuels and how they play a role in the overall water pollution, air pollution of our current situation where we live. And then we're looking at manufacturers, consumers, and industrial goods. And here's my PFAS. That's the forever chemicals that are coming off of things like Teflon, some solar panels, things like that. We have to look at what we put into the system and how it does eventually potentially cause pollution throughout this region. Really, how bad are we? Really, when we look at this. So we'll start somewhat local. 53% impaired for streams and rivers. 47% is in the good range. We get into lakes and ponds. You think about lakes and ponds. A lot of these lakes and ponds you're going to find in our rural areas, or they're going to be near where water runoff can get into them. And that water runoff that's entering into these small lakes and the ponds, what's it carrying with it as it goes to them? I was a cattle farmer many years ago, and we had a 3/4 acre pond. And you think about that. What's the water quality in that pond? Well, we had it bermed all the way around, so no water from surrounding crop fields could migrate into the pond, carrying it with it nutrients or potentially pesticides. So it was designed by NRCS to try to prevent that from occurring. But there's a lot of water bodies that are not protected. And what we do in our farm fields, what we do in our urban sectors can create problems for them. Then you get all the way over here. Let's just talk about the Chesapeake Bay. And the value the Chesapeake Bay brings us, we know. But when we look at the potential for problems in the Chesapeake Bay, you can see that 80% of our bays and our estuaries are impaired. 20% are not. That's a concern. We've got to look at water quality. How could we drive us back to a very clean Chesapeake Bay? It's going to take a lot of effort and a lot of different avenues. And unfortunately, with all the roads and all the people, it makes it even tougher. So this data comes from EPA as recently as 2019. Now, you might say, well, that's old data. Really not when you're coming to how fast we can turn data over. Not locally. This is Lake Erie. But look at a satellite image of the algal bloom that's occurring in that area. Now, yes, this is enhanced so we can see it, but this is something we can also see in the Chesapeake Bay. You know, you look at that water, got a green tinge to it. What does that green tinge tell you is there? The green tinge is telling me that I am seeing, if I take this the jump, I'm seeing the effect of nutrients, but I'm seeing algal growth, microscopic material growing that is going to prevent sunlight from penetrating into the water to provide the ultraviolet light to the submerged aquatic vegetation, which is very, very important. And then as that algae dies, the algae consumes oxygen, which creates dead zones in the water so that we have a greater amount of problems for the aquatic life that are trying to live there. So we don't want to see that. Now, unfortunately, in Maryland, we know that we will see this on occasion occur in the bay. We can almost predict a relationship between a heavy rain event in Pennsylvania and a flush of algae in the Chesapeake Bay, because when we have a heavy rain event in Pennsylvania, the water flows down the Susquehanna River, and we get concerned at the Conowingo Dam. So we open up some extra floodgates. Behind the dam is sediment, nutrient-rich sediment containing phosphate, amongst other things. And that flush of sediment comes down, and we see an algal flush. That when I see a water body that's like this, that's a real concern. That's turbidity. That's soil that's moving downstream. It's bad enough we're losing soil. The problem attached to that is the soil particle has bonded to it nutrients. So I'm seeing nutrient loss that is flowing downstream as this turbidity, as these soil particles slowly settle to the bottom. They leave a legacy of things like phosphate just literally sitting on the bottom of our streams. So literally, if I were to go and I were to eliminate all animal agriculture in the state of Maryland, if I were to take care of all the deer, all the geese, eliminate all phosphate-bearing products on any crop, we would still see a legacy of phosphate in our stream bottoms for 1 to 2 decades. That's how much phosphate's literally laying there. So we look at that and we have concern because we are losing soil, a very valuable resource, but we're losing nutrients with it. So we have to be concerned. We really have to be concerned. So we focus on pollution. We focus on 2 types of pollution: point source, non-point source. It's real simple. There's the end of the pipe. I can see what's coming out the end. Point source pollution. I can look at the stack. I can see what's coming out the end, the top of the stack. Point source pollution. So I can see that. Wastewater treatment plants, confined animal feeding operations. So I've got water that's funneled through and then flows out. Then we deal with a much bigger type of pollution, the non-point. It's diffused. I don't see it necessarily. I'm not able to say one thing is going to change it. I can't put a plug in the end of the pipe and I'm going to stop it. So it can come from all sorts of land uses. It can come off of your own lawn. It can come off of farm fields. These are the things that drive best management practices so that we can try to keep rainwater where it lands. So when we have a storm, we want that moisture to soak into the ground so that it's not carrying nutrients or soil off and carrying it downstream, creating bigger problems. So we really do develop a series of best management practices looking at cropland, looking at pastures, and how we manage the nutrients. Pastures, the nutrients there most often are going to be livestock manure that's deposited. So we have to remember there's lots of different things we can do. Probably one of my favorite photos. This came from Westminster, Maryland. This is Route 140. McDonald's is just across the street for those of you that know Westminster at all. Lots of impervious surface upstream from this. This is in a very heavy rain event. There's not farmland here. We are looking at an urban setting, but look at the turbidity that is in that water. It's carrying with it all sorts of pollutants that we have to be concerned with. So it is not just agriculture that has to address this. Everybody has to address the concern that we have for water pollution, nutrient movement, soil movement. We all play a role, but then we have to decide where can we go? What can we do that's going to give us our biggest return for the least amount of dollars? And that's always something government has to look at. Understanding the hydrologic cycle. Really, how do nutrients move? It starts with the fact that I've got rainfall that falls to the earth. Now, what type of a surface does it fall onto? Is it a densely covered crop field? Is it a heavy growth pasture? Is it a recently tilled field that doesn't have anything on it yet? We can see surface runoff, and potentially with that surface runoff, we are going to see soil containing nutrients, and in some cases, we're going to see clear water that contains nutrients. If I'm in the optimum or excessive range for my fertility index value on phosphate, I've used all my bonding sites up in the soil. So now I've got free hanging phosphate. And I can lose that free hanging phosphate simply because I'm having water leave the site, because it's not bonded anything. We see some of it moves into the soil. That's a good thing. But it can carry with it things like nitrogen. Why do we restrict the application of manures during what we call the blackout dates? Because we want to make sure that the plants are going to be able to uptake the nutrients when the manure is there and starting to break down. So it can get into the soil, which then can also feed water bodies. We see the fact that, from the ground, from trees, from crops, we have evapotranspiration. So that's where water is leaving the plant, going up into the atmosphere, and recharging the atmosphere with needed moisture that can allow it to rain again. So we want to think about that. Some of our soils are deeper to rock than other soils. And as you move across the state of Maryland, you will find some very deep soils. And then you'll get into some areas, you get into very shallow soils above rock. And once it hits rock, it's got to be able to get through the fractures in the rock to get inside into the aquifer. And in some cases, the fractures in the rock and the soil particles themselves will hold that water for a period of time. Time of year is very important. When we think about applying nutrients so that they can be utilized by a crop is really, really important. And agriculture has moved into a period of time in which we are doing this so much better. We are able to put nutrients down when they can be best utilized by the crop. So you look during the primary growing season, May through August. So we see rainfall coming down. That's the R. The E and T, the evapotranspiration, we're seeing things potentially going up. We're looking at the P. Notice it's a smaller P, smaller arrow. The percolation going deep into the soil is not great because it's getting down in the root zone and the plant's grabbing and making use of it. So all good. Surface runoff is somewhat small because I've got crops that are slowing the movement of water across the soil surface. I'm looking at pastures that, when they're well managed, they're going to limit the flow off site because I'm leaving adequate forage there. We get into the fall. You think about the fall. We're moving into harvest time. And the state of Maryland has a tremendous cover crop program, in which we are promoting the use of cover crops. In some cases, we are planting cover crops prior to the harvest of the crop on the field. We're spinning on with aerial seeders, with helicopters, with drones. We're putting on cover crop seed well before the crop is harvested, so it gets a chance to be established. So we are starting to uptake the excess nutrients that might be on a site, because when you're getting into this September to November, the corn is drying down, the soybeans are drying down, they're not sucking up nutrients anymore. So if there were leftover nutrients, the cover crop is going to sequester them. It's going to keep it in that upper surface so that it could be utilized for next year's crop after I terminate that cover crop. So we see surface runoff is larger in the fall period. Evapotranspiration is much smaller, cooler temperatures. My rainfall, one of the things you're going to learn about rainfall in the state of Maryland, it's pretty much even every month all year round. The way the rain events occur might be different, but the inches of rain that I receive per month remains about the same. Percolation is a little bit more because I don't have the roots grabbing the moisture that's moving into the soil profile. So that's good. But we get into this December through April, depending upon the year. This year, MDA told farmers, you can start applying nutrients prior to March 1. That is a variable on the ag side because we had a warm winter, soils were warm, wheat was coming out of dormancy. That's fine. But you look in that period of time, evapotranspiration, very small. We have rainfall, again, about the same. Percolation is more because I don't have a lot going on. And, hopefully we're not looking at a frozen soil. Frozen soil is hard to get moisture into. And surface runoff, again, is going to be about the same, So we're looking at different periods of time of the year give us different opportunities for holding nutrients or losing nutrients. And that's where we've really come a long way in agriculture. We have our blackout dates. We don't apply nutrients. We don't apply manure unless it's an emergency. And we look at trying to put the needed nutrients on the crop when the crop can make the best use of them. You go back 40 years ago, a majority of the nutrient needs for, let's just say, a corn crop went on prior to planting or right at planting. We didn't come back and put anything on once the crop was in the ground. We didn't have really good ways of doing it. We've come up with fertilizer products that have controlled release. We can use some products that will have extended release rates over up to 12, 14 weeks. We have the ability of straddling rows now. So we can do a lot of things along that same line. We look at it in a graph, and let's look at an Eastern Shore site. Remember, Eastern Shore is not solely sand. So it's always important to remember It is not solely a sand situation. So my blue line, that's my rainfall. A little bit up, a little bit down, not a tremendous change on a per month basis. Then I look at my black line, potential evapotranspiration. Normally, that's going to be more when the plant's growing and I'm going to have some warmer weather, end of this week. We're going to see some of that. And you see, look, as we get into the June, July, August timeframe, it's pretty hot. We're going to look at the moisture in the soil itself, and then we look at drainage. And we start to see there's some interesting things going on. I'm holding a lot of moisture right here. Then it goes down as I get into my growing months because and it's going to be moisture that's in the root zone where the plant can make use of it. So we look at that and we start to think, okay, where in the growing year are my nutrient losses going to be a potential problem? And how can I avoid, mitigate applying a nutrient at a time so that I will not risk those seasonal losses to me? So in what season is our risk of nutrient loss the highest? When you think about it, when aren't the roots growing actively? When am I not going to be seeing the ability for the nutrient to be sequestered, be grabbed by a plant root? So we're going to look at, the period of time in which rainfall is the same, evapotranspiration is down, and yet plant need is low. So why apply during that period of time? Thus, the regulation makes sense. If I invest $1 in a nutrient on a field, I expect $1 at least back in the way of a crop response. But if I put the nutrient on at the wrong time, and it either volatilizes off into the atmosphere, or it gets soaked through the soil profile or across the soil profile and is lost, I don't get anything back out of that. That's real important. We look at, okay, what are some of the sources that we have? And then how does it really move? In the case of, wildlife are going to leave their residual. They're going to leave their manure, their urine on the field. There's N, P, and K in that. Can't get away from it. And some of that material is going to soak into the ground. Now, depending upon the depth of that soil, the depth to actual water, some of those nutrients can get below crop ability to grab and can then move down through the soil and get into the aquifer carrying things like nitrogen. We look at the potential for runoff, erosion, poorly managed pasture site. We all see them. Too many animals, too little area. We don't want to have more than we really need. So I'm going to keep the animals on a real small site. Yeah, I'll feed them hay. They'll get food. They'll get water. But they churn the ground up so much that we have little cover. So my potential for erosion is there. Years ago, we used to tile fields. We would put drain tile in to take excess moisture away. Do you ever wonder where the drain tile empties out? Not in the field, usually downhill, which is going to be pretty close to it being able to travel to a water body. The nutrients that flow through the soil could get picked up in this drain tile, get a quick exit over to the potential of going into a stream. It's especially nitrogen. Again, the erosion, we look at N. We look at P, really, because P bonds to the soil particle. And when I see erosion occur, the muddy water, if it is a nutrient-rich soil, is going to carry with it, unfortunately, the nutrients. So lots of different things. So we see this, the animals are there, but yet they're transporting the nutrients to a different location where we didn't want them or need them to be. So we look at the two elements that we are really regulating, nitrogen and phosphate. So nitrogen can be lost very easily through leaching. Even in the best management models, if we have that really horrific storm that occurs when we didn't anticipate it, we have the potential of seeing nitrogen losses through leaching. It'll simply percolate down through that. That potentially is then going to contaminate our groundwater. So we want to think about that. We really want to think about that. Surface water, okay? We're seeing overland transport, and it's going to move it to streams because basically all water runs downhill and it's going to potentially get there. So N and P are the two elements we really focus on. Phosphorus, soluble P, as I have said, can be lost when I have surface runoff, when I have erosion. So we need to be aware of that. So I have the P that is bound in sediment. That's the turbidity, the muddy water. So I see the soil particle. I need to equate that immediately to there's potentially bonded nutrients there. That soil in its movement is going to create a problem somewhere downstream. So phosphate typically does not leach through the soil. Phosphate typically is going to leave a site either in clear water, washing off a site, or in turbid water, erosion water, that is carrying with it nutrients. The problem with clear surface water is normally a problem when I'm not paying attention to the nutrient analysis. And I look at that nutrient analysis and it says I'm in the optimum or excessive range, and I apply P anyway. Because when I'm in those upper ranges, the return on investment of phosphate for the crop is going to be minimal. You know, these names were not chosen arbitrarily. You know, through many decades of research, you know, we have determined that there is a return on investment at times. And then after we get beyond that level, we need to reconsider what we're thinking about utilizing that particular nutrient. So we look at nitrogen on the left, and we look at the fact that some is taken up into the plant. That's the green arrow going off to the right. I do have concerns with nitrogen volatilizing into the atmosphere. Water-soluble nitrogen that is applied and we have a real warm event, we have the ability of that water-soluble nitrogen literally volatilizing and going off into the atmosphere. We have the denitrification aspect to it. We do see some amount of runoff through erosion, but notice we're seeing quite an amount of risk of it moving down through a soil profile and then getting below plant roots where it can't be utilized, and then eventually getting in and affecting water quality, aquifer quality, things like that. So we want to really be aware of that. You know, you go back into the 40s and the 50s, 1940s, 1950s, you know, you looked at barnyards and you looked at the development of where we put the house, the barn, the well. And we found in the old animal agriculture that in a lot of cases, we had the nitrogen literally getting down into the water. And that's where we had the concerns over the blue baby syndrome. Most of you are probably not even familiar with that anymore. The nitrate levels in the water were so high. So, you know, we've really worked on that. We look at P, phosphate. Notice we don't see a tremendous amount of phosphate leaching down through the soil profile. Most of it's going to be used in plant uptake, but then we have this runoff, clear water, or erosion, turbid water, that is going to carry with it nutrients. That's where our concern is there. Again, that's why there is a coupled response. Nutrient analysis says I fall into this fertility index value range. That means I can or cannot apply a phosphate-bearing product as part of my fertilizer plan. And as we look across the state of Maryland, we see some regions where the soil PFIV, phosphate fertility index value, is in the optimum or excessive category, very often in the excessive category. Usually, this is coupled with a history of animal agriculture. Because, you know, we look at the fact that we have animals, and unfortunately, animals give us what? Manure. Manure carries with it nutrients. And there was a period of time that manure was gold because we didn't have synthetic nitrogen. So manure became a very valuable source of nitrogen. But then, thanks to the Germans, we were able to synthesize nitrogen. By the way, where does nitrogen come from? Right there. 78% of your air is nitrogen. And through a process of pressure and heat, we're able to synthesize that out, precipitate that out. Then manure became a little bit of a byproduct. It was cheaper to buy synthetic nitrogen than it was to manage manure. So we just, we used it, but we didn't pay attention to what we were doing with it. Now we pay very close attention to the manure, not just from the nitrogen aspect, but also from the fact that depending upon the livestock, there can be a phosphate aspect to it. So again, we find that where we have seen a history of animal agriculture, our phosphate levels will be higher. So we really need to pay attention to what that nutrient analysis tells us. And by the way, when you get your nutrient analysis back, they very often give you recommendations at the bottom. Ignore them, because those recommendations are based upon the state in which the test was run, not where the soil was from. So you have to take their numbers and you have to put that into our charts. And it's not, you don't have to become a chart wizard. It's pretty simple. And you need to find out your lab. And then where do you fall in the 4 categories? Low, medium, optimum, or excessive. That will then dictate to you what you can or cannot do on a site with the addition of added phosphate fertilizer or manure. Yes, we can control the use of manures. If we have too high a phosphate issue, we have to. We look at normal rainfall, then we look at storm flow. Normal rainfall is what we call baseline. Just what am I going to receive? How does the soil handle it? Then we look at storm surge. And the fact that storm surge can create additional runoff. Best pastures in the world. No till with cover crop. If you have a 4-inch an hour rain event like Florida was receiving last week, like Texas got 2 weeks ago, the risk of water runoff still exists. So we have to look at that. You also have to recognize that in urban areas, many urban areas, storm water flows through wastewater treatment plants, which creates its own problem. Because the wastewater treatment plant is designed to handle X amount of water, and I've got that storm surge flowing through. At times it creates a problem for them, and they have to literally open up gates and allow excess water to flow, by the way, which contains pre-treated sewage. So we have to think about that. So understanding when I'm looking at setting things up, my baseline. What am I going to expect on a monthly basis in an average rainfall? Then what am I going to look at in the way of what a storm flow is going to do? So I need to look at that, and I need to balance that. I really need to balance that. And we try to look at that, and that's part of the reason we look at buffers around streams. Do streams ever leave their banks? Yes. Yes, they do. We have to understand. Rare, yes, but they do leave their banks at times. So base flow, fed by groundwater flow, but then I get storm flow, which can be tremendous. And unfortunately, I'm going to get higher levels of N and P with storm flow than I'm going to have with my base flow. Let's look at 3 cropping systems. Forested area, pasture, cropland, and then mixed. And I look at, while I'm paying attention to this baseline versus storm. Notice in a forest area, why don't I have much concern with storm flow in a forest area? I've got that dense leaf litter. I've got the canopy that slows the movement of water down. So the heavy storms, I'm not seeing it beat the ground. Even in a winter period of time, I've got all the leaf litter. So as I look at that, I look at the amount of nitrogen potentially going to leave. Get over to pasture. Pasture doesn't do too bad, with base flow. Storm flow, it can get bad. Cropland. Is cropland conventional tillage? Is cropland no-till? We look at the amount of base flow that's going to occur, nitrogen, okay, that I'm going to see in the water coming off of it. It's higher than the previous 2. Slightly less than my pasture area. And then mixed. Looking at a larger watershed area and looking at how that is going to be affected by having some trees, having some pasture, having some amounts of cropland. So again, under base flow, pretty good here, not as good here, pretty good, real good. So we're not seeing a tremendous amount of nitrogen loss. But as we go to more intense use of the ground, then unfortunately we have the potential of seeing more nitrogen try to move off site. We value the bay. We value our streams and rivers that move through the state of Maryland. When we treat them well, the aquatic life does well. When we don't pay attention to what's flowing into them, and we're seeing more nutrients and other pollutants flow into them, the aquatic life we like tends to decline, and things that we are not necessarily interested in tend to benefit. So we talked earlier a little bit about the algal blooms. Those algal blooms create problems. Again, they shield the sunlight so that the UV can't reach the submerged aquatic vegetation. That submerged aquatic vegetation provides places for the fish fry to hide so that bigger aquatic life can't get them. Then we see when the algae goes through its cycle and dies, it consumes oxygen in the decay process. And through that decay, we have tremendous amounts of CO2 in the water. The aquatic life doesn't live off of CO2. So it struggles even more. So, we see different things that can occur in the water based upon how we treat the water. In Montgomery County, we do a program called Close Encounters with Agriculture. And one of the stations this is for 4th graders. We're trying to teach our 4th graders about the importance of agriculture and have it do its job well. and we talk about what we can find. We walk up to a stream and we just survey what's in the stream. And that could be a real indicator to the quality of the water body. Something as simple as what's living in the stream. And we help them learn about different types of aquatic life that we will see and how to identify them and which are the good ones and which are the bad ones. Then we look at what our role as individuals are in the pollution of that water and what we could do to change that. So we want to drive more to this because as we drive here, we're losing a lot of the things that are going to promote a healthy water body. And we've seen that for the past several decades with Chesapeake Bay. We've made some changes, we've made some improvements, the letter grade has improved. Are we to an A? No. Are we making changes? Yes. Is there room for more improvement? Yes. But you live in Maryland. We're focused on Maryland. And we look at that and we start to think about, this bay that we have here, really how big is it? Okay, we're looking at over 4,000 square miles of surface area. Relatively deep, 21 foot deep. Though as I've been paying attention to the Key Bridge and how they wanted that channel at 50 foot, okay. We've got a lot of area that plays a role in the bay. When we look at the major pollutants, it's N and P. In agriculture, do we use a lot of N and P, nitrogen and phosphate? So could we play a role in the cleanup of the bay? Could we use our nutrients well, still harvest our crop, and not be responsible for additional pollution in the bay? Yes. So, we look at this. The Chesapeake Bay watershed, if a raindrop falls, where's that raindrop going to go? For the state of Maryland, it's a majority of the state of Maryland. You get out here and you get to Oakland, yeah, it's going to go the opposite direction. But most of the rest of the water flows down towards the Chesapeake Bay. But note that it's not just the state of Maryland. It goes beyond the state of Maryland, goes up into New York, huge section of Pennsylvania, Maryland, Virginia, West Virginia. They all play a role. So we're in this together. Here's part of the problem we have. When you look at land use, and the green colors are more open ground, the pinks, etc., it's more urbanized ground. What's closer to the bay? Got a lot of urban area that can flow to the bay and carry with it many things. And we have to be attentive to that. We have to understand that we all play a role, but the role we play varies depending upon where you live. So you can barely see the outline of Maryland. This is Maryland through here. So these are some of our urban counties right there. So why do we spend so much money, time, effort on the bay? We don't hear about this being a concern around the rest of the world. Well, because when we look at the watershed area that flows into the bay, notice how large our watershed area, the ratio of watershed land area to water volume. Man, look at the bay, it's huge. It's huge. So we have to be attentive to that. Now, we have taken lessons from other areas. The urban side took a lesson from the Great Lakes region and applied some of their technologies and regulations here. But, we're really playing a big role. Now, one of the important things to think about is our soil. One of the interesting things, once you really get into and learn Maryland soil, is the fact that Maryland has many, many different soils. The soil circle applies to everyone, no matter where you live. But the minerals that make up your soil, the depth of your soil, can change greatly. We look at our eastern shore. Going to have a thicker soil, going to have typically a larger particle size, which means it's going to drain a little bit better. And we pay attention to that. We'll talk about soil size and its relationship, sand, silt, and clay to one another, and how that plays a role. We look at through the Piedmont area. We are in thinner soils, typically 3 feet of depth, getting into more of a clay, which is a finer particle, much finer particle soil through that as compared to the coastal plain. And then we get into some of our more challenging soils, thinner soils. You get up into Washington County. As you drive up Route 70, look out on either side of your car and just look at the rock outcroppings that occur. Thinner soils, okay? Rocky, great range of different soil textures. I spent a majority of my life on a clay-based soil, and I've worked with clay-based soils for a tremendous part of my life and got very used to working in clay soils. And now I've moved and I'm in a soil that is a very sandy soil, and I'm having to rethink a lot of things as I just do my personal garden. Understanding soils is very, very important. Very, very important. Sand, silt, and clay. I teach a soils class. And in my soils class, I try to always start my first day. So what kind of soil do you want? Anything but clay. Anything but clay. Why? Sand, in relative proportion, is a basketball. Silt is a ping pong ball. And clay is a pea. When you take many basketballs and put them in a container, you see the amount of room that's between each basketball. That's why sand does not hold on to moisture. The surface tension of the water to the sand particle, it binds to the sand particle, but the area in between allows it to drain through. Silt, the ping pong ball, so top is sand, getting into silt, the middle photo, the areas become smaller. And then clay, in a well-structured clay, has the smallest pore space and is able to hold on to moisture better. Sand does not hold on to nutrients very well. It's not a real good holder of nutrients. So we typically, you think about golf courses, you think about lower eastern shore, real sandy soils. We have to think about how we spoon feed our crop to make sure that they get the adequate nutrients throughout the year. We look at the particles themselves. There's that larger sand particle in the upper left corner, and we look at that and we think about that, and we get over and we look at getting over here, some of our upper right, some of our karst-based soils in which we can see certain minerals that will literally dissolve away and create openings for greater quantities of moisture to drain through it. And then we look at a fractured porosity in which we're looking for channels for the water to move through. And remember, when water moves, what moves with it? Nutrients. The potential, especially for nitrogen, to move with that. So we pay attention to the soil type. That talks to us a little bit about nutrient use and how we're going to handle that. Now, we look at what's in the bay that's a problem. So nitrogen, upper left corner. And where is the nitrogen coming from out of this pie chart? And you look at ag, synthetic fertilizers being at 17%, and then ag manure being 19%. That's a big percentage of what's up there. You start to see septic tanks. Septic tanks have a concern. Do they function properly? Because when they don't, they potentially leak and that gets out. You look at municipal and industrial wastewater treatment. The state of Maryland has spent a lot of money in the past decade, going on to trying to upgrade wastewater treatment plants. And that's very, very important. So we look at the fact that agriculture, through its use, puts out a tremendous amount of potential nitrogen into the bag. We're not the only one, but just look at the amount that we do. You're going to need that on a slide coming up. You look at the phosphate, okay? Agriculture manure, 26%. Agricultural fertilizer, 19%. Even with the invention of no-till agriculture, going back literally into the 1970s, we still see segments of traditional agronomic agriculture, plowing and disking. Potential nutrient loss, potential soil loss. So even though we know we have better technology, we still have some people that have not basically embraced that. We also see 31% urban suburban runoff and in-stream sediment. So again, like talked earlier, we have an urban program. We're focusing more agriculture here. Notice 21% of phosphate is coming from municipal and industrial wastewater treatment. Sediment. Look at this. 60% of the sediment is ag sediment. Can we do better? Can we really look at that? Notice 21% is natural sources. So you can't eliminate it necessarily altogether. How do we invest our dollars? I've heard oh man, ag's overregulated. Okay. Let's look at how I invest your tax dollar and what kind of a response I'm going to get. So as I'm trying to reduce the pollution that's coming, I can look at right here on a per pound basis, $1.50. And that's going to be restore or construct wetlands. Wetlands are like sponges. Things move in and it slowly allows it to percolate in. Putting in grassland buffers, $3.20 per pound versus the wetlands, $1.50. Conservative tillage. Going to invest $3.20 for every pound of return I'm going to get in reduction. Cover crops. You want to talk about, I'm proud of the state of Maryland for having a cover crop program. Cover crops are very, very important. It takes and it puts something on the ground during those winter months. It's going to reduce erosion. It's going to sequester nutrients. So a win-win. Nobody wants to lose soil. Everybody wants to keep the nutrients that were not used by a particular crop. Remember last year how dry we were? So if the corn, the wheat, soybeans, they didn't take things up, let's grab it, let's hold it, let's return it for the following crop year, and then release it. Then we get into waste. So notice the jump, $4.70 to $15, wastewater treatment plants. Changing wastewater treatment plants, upgrading wastewater treatment plants. Enhanced nutrient management. Wastewater treatment plants upgrades, it's requiring a lot. Look at this one. Stormwater management. And we look at many municipalities that basically take the water that goes down the storm drain and it ends up in the sewage system. So to change that in total, that's a huge bill to take. lot of infrastructure changes that would have to occur there. So, you know, we look at these. So why do we look at ag? Smaller investment, bigger results. So it makes sense to, in many ways, look at that and try to see how we can take the fewest amount of dollars and get the biggest response. That's how this was developed. When we look at typical local agriculture, we buy fertilizer, we apply it to the field, the crops take it up, we take that, we run it through the livestock, we get a byproduct, whether that be milk, meat, eggs, etc., which goes to our local stores. We take the manure, we put it back on the same field as a nutrient source. So we're keeping it local, somewhat balanced, somewhat balanced. But then we look at, unfortunately, the way agriculture has gotten in recent years. We apply the synthetic fertilizer to the soil to produce a crop. The crop is harvested, goes to a feed mill. Where does the grain go? Well, if you didn't learn anything from the Port of Baltimore, there were soybeans. I had a friend who had soybeans on the dolly. Yeah, he had several containers of soybeans on the dolly. So we ship them globally. But let's say we don't even do globally. So who am I going to pick on? Can't pick on you. Who lives in any part Anne Arundel County West?
I live over by
Okay, so if we're going to produce a corn crop on your property, and your corn goes to Lower Eastern Shore into poultry houses, where's the manure go? Manure stays there. Got to come up with a way of moving that manure, because that becomes, see, I can transport the synthetic fertilizer pretty easily. We do have a way of moving manure. We have something called the manure transport program. But the farther I need to move it, the less economically it works. So while we have a concentration of poultry on the Eastern Shore, while we have a concentration of dairy in Frederick and Washington County, we look at the fact that we've concentrated manures there. We don't want to move them too far. It costs money to move them. How many of your neighbors want to be behind a manure spreader going down the road where the manure spreader is going 15 miles an hour? You're not going to be happy about that. So this is part of the problem that has occurred with the global nature of agriculture right now. And we have to look at this balance and trying to make it work. Not necessarily easy. You know, part of the reason that we have this regulation is because of concentrations of certain things like phosphate in certain regions. Here becomes the problem. Tremendous numbers of inputs, okay? Feed, animals, irrigation, fertilizers, things like soybeans and clovers. We're going to raise a crop, animal or plant. We're going to have some emissions occur. We're going to have some soil removal, some loss of nutrients. And then we've got a few things going off, but they're not local. They're going to a much broader area. And we start to think about that. We have to manage those outputs as well as we manage the inputs. But then today, with the high price of travel, I won't even say diesel fuel, but travel in general, whether it be train, whether it be truck, whether it be boat, we try to keep it a little bit closer, because the closer we keep it, the cheaper the product I want to use will be. So we have to look at that. So the inputs for 120 cows, 29, we'll say 30 tons of nitrogen per year, 2.6 tons of phosphate per year to produce the crops, to grow the cattle, to produce the milk, etc. So just say 30 tons of nitrogen in. I've got 6.9 tons of nitrogen going out. Okay, so here's the imbalance we have. How do I deal with that? How do I cope with that? So one of the things we've developed is the 4 R's. And this is really something that has really grown in recent years. When we think about applying a nutrient, I've got to put it down at the right rate, at the right time, put it at the right place for the crop to use it, and I need to use the right source. So this is learning about really thinking about crop growth and how I'm going to do it. And this is part of what nutrient management really is about. When you write a nutrient management plan, you're not going to tell them to put all their nitrogen down on March 1 for a corn crop. Not the right time. Corn's not in the ground March 1. I don't have roots that are going to be able to take it up. So we want to look at using this 4R process to benefit us. That's going to help reduce potential for nutrient pollution. It's all about balance. Apply manure and fertilizers at the appropriate rate, at the appropriate time. Avoid manure usage because of the phosphate-related issue on high phosphate-laden soils. Then here, notice this. Consider realistic production potentials. You might want 250 bushel per acre. You might be able to achieve it. Was it economically feasible? Did you make money at 250 bushels per acre of corn for all the inputs you had to put into it to get there? And by the way, the losses that went with it. Whereas if you had set a more realistic production goal, could you have been better off? So we want to look at that. We want to consider the best management practices that we can use. So looking at a yield response to a nitrogen input. Nitrogen costs money. The application costs money. So it's not just buying the product, it's getting it out. At what point in time do I say enough is enough? When is the break-even point reached? So we really have to look at that. So we look at the fact that the addition of 40 units of nitrogen gave me a fairly large increase in yield. But if I get up here and I'm adding another 40 units of nitrogen on top of what I had already applied. I'd already applied this. I add this additional. Notice the curve flattens out. My investment of $1 is not returning as much. Was it worth it? That's where we have to really look at this, and we have to look at that return on investment. So I only got a 2.5% increase yield increase versus a 16% increase in yield. So I have to really look at that and decide, is that really worth the extra dollars I invested? And remember, you don't have control of everything. So we want you to look at economic yield as much as total. That's very important. I work with a farmer, Randy Stabler. You don't know Randy? Sorry, you don't have the opportunity to know Randy. When nutrient management came out, he was opposed to nutrient management, hated nutrient management. This is going to hurt me. Randy Stabler says this is one of the best things that's ever occurred. It's made him sharpen his pencil. It's made him look at economic return, not just total yield. Randy Stabler uses it well. We want to consider economic yield, return on investment, ROI. So, as I said, if I'm at 150 pounds of nitrogen already on the ground, and I want to apply another 40 pounds, and I only get a 2.5% yield increase, at the cost of nitrogen, was it really worth it? You have to decide. You really have to decide. 2 slides. Okay, corn yield and valuable end of season nitrates in Maryland. So what's going to be left over and what do I have to be concerned with? So you start to look at this. How much nitrogen was applied per acre? And what's left over at the end of the season? Notice, after I get here, look at the amount that's going to be left over. Going to be leaving a lot. For what? Did you sequester it? Did you grab it and not let it get away so you can make a benefit from the next crop? Or did you lose it altogether? So this is where the nutrient management advisor is going to determine, that's going to be my best potential yield goal. Yeah, you can want 250 or 300 bushel per acre. Doesn't mean you're going to be in business in 5 years. You can apply all that fertilizer and it can cost you more than you get back. You want to apply the nutrients that are going to give you a net return. That's going to be what you're looking at. So we start to look at how can we reduce the potential for pollution. That's best management practice, what it's all about. Field buffers. They slow the movement of water from a site before it can get to another site where it could be a potential problem, like a stream. No-till. I am a tremendous fan of no-till. I believe in it. Even if we were to go to conservation tillage, we see a real push in recent years for small vegetable operations. A lot of small vegetable operations are going to till their sites 2 and 3 times a year. That's soil loss. That's nutrient loss. The more we can reduce tillage, the better off we're going to be. Again, I'm proud of the cover crop program the state of Maryland has, a best management practice that the state is helping pay for. So very, very useful in the fact that we're putting crops on. That's what you see across many of these fields through the winter time. And then it is terminated in the early spring and we can plant into that. Proper use of fertilizer. Remember the 4 R's. Keep that in mind. Rotational grazing. Make your pasture last the longest period of time possible. You've got 10 animals and you've got 30 acres. They're going to wander around and pick what they want. Not necessarily make the best use of the forage that's there. Keep them into smaller areas, make them eat everything down to a safe point, and then move them off. That's going to be a benefit. Forest land buffers around streams. They keep streams cooler. They provide the root system along the stream edge. They also keep our crops from being that close to the stream edge. That's going to be very, very important. I'm going to jump to the top of stream exclusion. We don't want animals going and standing in the streams. I know it's going to be hot this week, and they're going to love to go stand in the stream, maybe even lay in the stream. But when they defecate or urinate, that's nutrients that were just put into the stream. Want to drink that water downstream? Just think about that. And then manage manure well. Learn how to manage manure well. It is a valuable asset. Use it as if it's a valuable asset, but pay attention to your nutrient analysis and use it where you can, not where you shouldn't. Does that make sense? And the old man is done. I passed the test. I can tell you, it was terms of